Okay, so at the moment we're getting fairly close to real world accuracy. We have stars in the right positions, they're the right sizes, the right colors. The constellations are looking really beautiful. There's one key element that we're missing though, and that is time. Stars don't stay still, although it looks like it. So what we're going to introduce is the time element of each of our stars. This is something that's really special about this HYG database. I'm going to go ahead and open it up. Open up this reference again. We have here in fields 20, 21, and 22, we have velocity, the Cartesian velocity of parsecs per year of each star. We can use this information to say, well, this is where the star is or was at the year. The standard year of measurement for most of them is 2000. So we're gonna say that all of them are from 2000, and then say, for example, a year later, whatever this velocity is, that'll be how far that star moves in that amount of time. Now, we're dealing with a lot of data. We're dealing with like hundreds and thousands of points. So using C# to do this, as in like say for example render a new mesh every frame, is not reasonable, and we don't have to do that. Luckily we can do all these calculations inside the shaders on the GPU. The GPUs are made for this sort of big data. Let's have a look at how we're going to do this. First of all, just like our colors, just like our magnitudes, we're going to go into our star info and we're going to create a new field. This is a public vector3 velocity, and the velocity is going to be very similar to this position vector3, except that the fields are going to be 20, 21, and 22. 20, 21, and 22. All right. So now our star infos have a velocity recorded. Let's make sure that's getting onto the mesh. So in our star mesh generator, again, because we're wanting to be cross-platform, we've got to think about how we're going to pass this data in. Well, there's a vector3 that's very common and widely supported on many platforms that we're not using in our mesh yet, and that is the mesh.normals. All right, so normals are usually describing in what direction is a face facing? In what direction is a vertex facing? What's its outwards direction? But we're going to use that for its velocities. So the normals are going to equal stars. Stars dot select for each star. The stars dot velocity dot toArray. Because normals are expecting a vector3, this will just work. All right, so now our mesh knows about the velocities. The last thing we've got to do is we've got to put this inside our shader. How we're going to do this, because remember, we're going to need to make this calculation for the stars and also those positions that the constellations are recording. We're going to do this inside of our utility class. And I'm going to create a new function. This is going to be called float. This is going to be a float for J2000, get J2000 offset. Now you may have noticed that I mentioned the year 2000. This is J2000. It's a common in this astronomical world. It's a common reference to the positions of the stars in the year 2000, kind of like a fixed point, almost like a epoch 1970 for us programmers or something. Okay, so what are we passing in here? We're passing in the position, vector float for pos, and also a float 3 offset. Okay, so how are we going to do this? offset. That's the wrong word. It's a velocity. Velocity. So what we got to do is we've got to have a certain value, which will be the current year. And what we're going to say is from that current year, how far away that is from the year 2000, that's how much we're going to multiply it by. Multiply the velocity by. Okay, so you have a position, right? You have a position. This is a position at the year 2000. And let's say the year is 2005. Well, then it would be velocity of parsecs per year times 5. So that's how we're going to kind of work that out. So let's say there's going to be a float J2000 offset. Now the interesting thing about this float is we're not going to declare it as a property in our shaders. Instead, we're going to be able to control it from the C# script. This is because later on we may want to put it inside a UI or something like that, or be able to control it with time and this sort of thing. Okay, so now we're going to say return pos plus velocity multiplied by J2000 offset. Okay, so if the J2000 offset is 0, that means the year is 2000 because it's offset from the year 2000 by 0. Let's make sure our star and our mesh vertex shaders are implementing this. Our star and our Constellation vertex shaders are implementing this. So instead of pos equals v.pos, we're going to pass in its position and its velocity. So let's go ahead and make sure that our mesh is passing that normal value, the normal, which is really a velocity of the star. Make sure we're passing that from the mesh to the shader. So in our app data, we're going to say float 3 velocity. I'm going to say VL, which is the normal. And from there, we're going to say the position of the output is going to equal get J2000 offset with v.pos, and the velocity is v.vel. All right, now we're going to give the exact same treatment to our Constellation shader. All right, so o.pos instead of I, this is I instead of v. That's confusing. I'm just going to make it I for now. All right, I.pos and I.velocity. Of course, make sure that we're passing in this velocity. So we say float 3 VEL, and that's the normal. Okay, so now we're passing in the velocity to all of our stars, which are then going to be affected by this J2000 offset. By default, that J2000 offset will be 0. So let's go ahead and make a little C# script which is able to edit that value. So I'm going to create a new class. I'm going to call this class. I'm going to create a new folder first. I'm going to call the folder settings. And inside settings, I'm going to create a new class called time manager. And for now, I'm going to keep this fairly simple using Unity. Oh, it's time manager .cs using Unity engine. We are going to have a public class time manager. When we're testing, at least, we certainly want this to be in a mono behavior, so we can edit values in the inspector. Yeah. Now we'll make it. I was thinking, like, do we want it to be a scriptable object instead? But I'm going to stick to mono behavior. Okay, mono behavior. We have a public float. This will just be called current year. All right, now we have a void on validate. That means whenever that current year is changed, we want to do something. And what do we want to do? We'll have a new function. This will be a void set J2000 offset. Pass in a float, which would be the year, float year. And remember, when we set our J2000 offset, it's 2000 plus the year. Plus the year. Is that right? No, the year minus 2000. Because it's got to be, yeah, 0. The offset of 0. So for example, if the year is equals 2018, we say J2000 offset, well, that would equal 2018 minus 2000, which would be 18. It would be 18 years past the year 2000, which would tell our stars how far they've traveled in that 18 years. Okay, so the syntax for this is shader dot set global variable, set global float rather, set global float J2000 offset, and the value that we're going to pass in is the year minus 2000. Okay, so now whenever we validate this script, we're going to say set J2000 offset with current year. Now the last thing I'm going to do is I'm just going to give a little range to this year so we can add a little slider, which is nice. Range between negative 100,000, we'll do for now, and 100,000. All right. Remember, because we've added a new field to our star infos, we will need to generate everything again. Generate, and while that's generating, we can have a look at what errors we've got. Float 3 to float 4. Okay, so I may have gotten that shader script to the J2000 value. It may be returning the wrong. Maybe returning the wrong value. Velocity, 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 velocity. Is it the normal? It's perhaps the normals are supposed to be a float 4. I'm gonna see if the velocity. I could have made a mistake here. Maybe the velocity, the normals are supposed to be a float 4. Just try that. Float 4 velocity. Float 4 velocity, and also in the utility, it's gonna receive a float 4. It could be converting. It could be converting that float. I believe what's happening is it's converting this of a float 4 multiplied by a float 3 is equaling a float 3. I believe that's what's happening. So we'll just change that to a float 4, which should fix it. Okay, no worries. And now we should, in theory, have the data being affected by our time manager. There we go, current year. Okay, beautiful. So it's working. Our constellations are freaking out. What's happening there? Okay, I just realized the oversight that I made. I'd added to the star meshes. We've added the velocities to them. We also need to add the velocities to the constellation meshes. So if I go ahead into constellation mesh generator, we also need to say in the constellation meshes mesh dot normals equals stars dot select s dot velocity dot to array. All right, that's better. Again, we're going to regenerate everything. Okay. I feel like I should do something while that's generating. Everything's looking good. Maybe just tidy up code a bit. Oh, time manager. I know what we can do while we're waiting. A really nice thing to do is to have the stars kind of floating around, as in over time they'll slowly change. So I'm going to have a new float, public float, like it updating over time. I mean, I have a public float. This will be years per second. And that'll equal, let's say, 10 years per second. And public bool auto update. Auto update. All right. So now in our update function, void update, we'll say if auto update, we want to increment the current year by years per second. Current year plus equals years per second times by time dot delta time. All right. Oh, and then because we updated the current year, we also want to set the J2000 offset. So I'll put that in there, and we'll say set J2000 offset current year. All right. So now we have our constellations that are in the right place. We can go over to our time manager. We can change our current year. Have this sort of like our constellation sort of wandering around. You'll notice that there's a few values that seem a little bit, like maybe they're accurate, but it's crazy. Like all the other stars are moving so slowly, and you got these outliers that are just flying around. Anyway, I'm gonna go ahead and press play so that we can watch the stars go by. Okay, so if I hit auto update, 10 years per second is nothing. We're going to do much more than that. So I'm going to bump that up to, let's see, oh gosh, I'm going to have to type it in. Years per second, let's say 50,000. Okay, there we go. All right. I'm going to quickly, this will be really worth it. I'm just going to add a quick reset button. This is the quick and dirty way to write a reset. Public bool reset. On validate if reset. If reset equals false, and set current year equals 2000, and set J2000 offset current year. All right. I'm also going to have the default current year to be 2018. All right, that'll give us something to really nicely to be able to play with. All right. So make this nice and big. I'll have years per second. Let's say 10,000 years per second. Auto update, and we can watch them slowly drifting around. You know what would be awesome? Would be to have colliders on them and find out who would be the first two stars in our neighborhood to collide with each other. That would be so cool. Okay, and then we've got a reset button. Just bring it back to normal, and then watch them drifting around again. Of course, we could make this years per second. I could make that a negative value. See what time, what the galaxy looked like when Earth started or something like that. Could we do that? I bet we could. All right, so if I set, what is it, 13 billion years? All right, so if I say auto update off, all right, so current year equals, I wonder if I can do this. Is this going to let me do an outside of range value? Negative 13 billion. 0, 0, 0, 0, 0, 0, 0, 0, 0. That's a big number. I don't know. We might need a long for that. Oh, should I do it? Oh, no. I'll do it maybe another time. Oh, now I really want to do... All right, I'm going to do this. I'm going to see what the Earth looked like 13 billion years ago. All right, so this need to be a long. I believe a long can go up to 13 billion. This is a guess here. All right, the current year equals... Okay, let's see if this will work. Convert float to long. Are you missing a cast? Line on 37. Okay, just gonna comment this out for a moment. It's gonna be really cool. Okay. Current year equals negative 13,000. That's 13,000. 0, 0, 0. That's 13 million. Yeah. And then 0, 0, 0, that's 13 billion. The Earth, 13 billion. This is too far out. I don't think this is necessarily very accurate. Let's see if we could zoom back a bit. Gosh, okay, this is really pushing the limits. I think, yeah, okay, that was a bit of a stretch. Well, okay, so now we know that maybe 13 billion is a bit too big. You know, this is a part of the experimentation and, you know, learning and all that. I'm just going to reset everything. All right, but please feel free to come up with your own ideas of what we could do with this sort of information. I'm sure there's a ton of interesting things I just wouldn't dream of. All right, I'm just going to go ahead and change this. I'm going to rename this game object to a time manager. Or time manager. Is that a child? Oh, no, it looks like a child. No, that's cool. Okay, current year is 2018. The camera's position, I'm going to reset. And okay, it's all looking good.